Hey guys, so we're starting our probability unit. So this unit is going to be really fun. Right now we're just going to kind of refresh our memories about what probability is. So before we do that, we need to talk about likelihood. Now, there's five different types. So the first one is an event is likely to happen. That means it's probably going to happen. So the probability is close to 1. Remember 1? It's because when we do probability, we do fractions and stuff. That's why it's close to 1. So it's probably going to happen. We're going to look at some examples. So it's not for sure, but it most likely is. Unlikely. So unlikely is it's probably not going to happen. So the probability is going to be close to 0. It's going to be a really, really, really small fraction or a really, really, really small percentage. It's probably not gonna happen. These probablys are really important. As likely as not. Now, when I first read that, I was like, oh my gosh, what does that even mean? As likely as not? Well, it's as likely as it's gonna happen as it's not gonna happen. So it has an equal opportunity of happening as it does not happening, which basically means your probability is a half. So it could literally, it's 50-50. It could go yes or it could go no just as easily. Impossible. There is zero way it's ever going to happen. Like, probability is 0. It is not going to happen. There's zero way I'm ever going to fly, so it is impossible I'm going to one day have wings and fly. And lastly, certain, it's 100% going to happen. The probability is 1. Remember when we have 1, because we're talking about fractions, so it's like 1 whole. So it's 100% going to happen. If it's raining outside, it's certain that it's raining outside. Obviously, it's obviously going to happen. So let's look at some examples. This first example says, try and cover it up. You randomly pick a green card from a stack from a standard deck of playing cards. A green card. Well, standard deck of playing cards, remember you have what colors? You have red and black. So you randomly pick a green card. Are we ever going to pick a green card? No. So which one of these do you think it's going to be? Hopefully you said impossible. It's never going to happen. You're never going to pick a green card out of a standard deck. Alright, the next one is you randomly pick a red card from a standard deck of playing cards. Well, you're picking a red card. Well, there's red cards, but there's also black cards. Isn't there half red and half black? So you kind of have a what chance? You have a 50-50 chance. Well, which one of these talked about having 50-50? Good. Hopefully you said as likely as not. It's as likely that I'm going to pick a red card as it is as I'm not going to pick a red card. The next one is you will walk out in the parking lot and see a white car. So if you walk out in a parking lot and you see a white car, are you for sure going to see a white car? No, so we're not certain. It's not impossible because there's obviously white cars. It's not 50-50 because there's black cars, blue cars, green cars, red cars, right? It's not unlikely because, there's probably going to be a red car, so it has to be likely. If you walk out in the parking lot, you are likely to see a white car. Alright, you pick a number less than 15 from a jar with papers labeled 1 to 12. Well, less than 15 includes 12 and 1, right? So if you pick a number less than 1 through 15, you're going to pick a number that's 1 or 12. So that's certain. That's 100% going to happen. You will draw a number that's less than 1 or less than 15. And finally, the only one that's left is you roll 2 dice. The sum of the numbers is 3. Well, think about how many combinations. You could get a 6 and a 6. You could get a 6 and a 5. You could get a 6 and a 4. You could get a 6 and a 3. Think about a sum is adding, obviously. So a sum of the numbers is 3. It's really unlikely it's going to happen. Now, it's possible. That's why it still could happen, but it's probably not going to happen. All right, so now that we've talked about the likelihood of events and we've brought up the word probability, we brought all it up, let's go back to 6th grade and let's talk about some vocabulary. Alright, so the first one, probability. What is probability? Probability measures the likelihood that an event will occur. And we write P and then the event. So probability that we roll a 5. That's how it would look. Probability that we roll a 5, that's all that means. Alright, the next one is an experiment. Well, think about it. An experiment in science, an activity involving a chance in which results are observed. An activity involving chance in which results are observed. Well, you observe experiments. So I roll a dice. That's an experiment. I flip a coin. That's an experiment. Results, I'm observing. Did I flip a heads or did I flip a tails? So over here I'm going to put heads or tails. What's the next word? The next definition is each observation of an experiment. Well, trial. Each observation, well, I guess that would really be heads or tails. So the experiment would be flipping a coin. So let's flip that. Flipping a coin. The trial is each observation, so you could get a heads or you could get a tails. And then the outcome is what happens. I flipped a heads. That makes sense? An outcome is what happens, each result. So the next one is an event. A set of one or more outcomes. Example, rolling a die and landing on a 1. Set of one or more outcomes. That's an event. So this is your event right here. Alright, sample space. This is a huge one. Sample space. A set of all possible outcomes. So I'm going to break. I'm going to show you this nice little, vocabulary word that I have. So sample space. We know that, get that glare off. Sample space, we could have, if we have a coin, we have heads or tails, right? If we have a bag that has purple, green, and orange, we could draw purple, we could draw orange, we could draw green. A dice, you have 1, 2, 3, 4, 5, 6. It's all the possible outcomes that could ever happen. Okay, so all possible outcomes of an experiment. Alrighty. Now, you might have seen this. The tree diagrams from last year. Remember, a tree diagram is an example of a sample space. So, flip a coin 3 times. Your first time, you could get a heads or you could get a tails, right? Okay, well then the second trial, after that, you could get, if you land on heads the first time, you could get heads and a tails the second time. If you land on tails, you could also get a heads or a tails. Well, one more time, remember, if you had a heads, and then say we get a heads and a tails and heads and tails, right? Because you have to remember which one you're going down. So you get a head the first time, you get a head the second time, and the third time, you can flip a head or a tail. So let's say we just flip a tail. So that's what would happen. So, over here, you have a tail, then you have a head and a tail, a head and a tail, a head and a tail, okay? Way to list all possible outcomes of an event. Okay, and what you do is you would take, if we're flipping a coin 3 times, we do 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Remember, you multiply everything together. Alright, so the sample space is all possible sets. So we're going to write tree diagram over here because that's an example of it. Now let's say I have a pizza. Here's my pizza. I can get 2 cheeses. I could get 4 toppings. And I could have 2 different crusts. Now what if I asked you, sorry, I'll zoom in. What if I asked you to find how many pizza possibilities could I make? Well, I'm asking for the sample space, right? So I want to do 2 times 4 times 2. There's 2 times 4 is 8, times 2 is 16 possibilities. Alright, now that's just a little example just to kind of refresh your memory. You should have gotten this last year. Your last one is a complement. Your last word is complement. Complement is the set of all outcomes in the sample space that are not included. So this is your word, this is your phrase that when they like to throw in the word not. So what's the probability of not rolling a 5? What's the probability of not doing something? Not is your keyword there. Alright, so let's look at some examples and then we're going to be done. We got probability and then we got to talk about complements and then we're done. So obviously, you're going to want to highlight, star, whatever you want, you're going to want to refer to this. Alright, so probability of an event is the number of times the event occurs over total number of equally likely. Basically, that's really wordy for sample space. Right? We're making fractions. So, what's the probability of rolling an even number on a number cube? Well, a number cube is just a dice. Don't let them trick you. Okay, well, first of all, let's list out our sample space. Our sample space, what are all the possible rolls we can roll? We can roll 1, 2, 3, 4, a 5, and a 6. So total number of possible outcomes, I'm going to put that in my denominator as 6. Rolling an even number is what the question's asking. So how many even numbers? I have 1, 2, 3. 3, 6 simplifies down to 1/2. So the probability of rolling an even number is 1/2. Okay, easy. What's the probability of picking a purple marble from a jar with 10 green and 10 purple marbles? Well, how many marbles do you have in all? That's what we're looking for our sample space, right? Our sample space is 20 marbles. So where does our sample space go? And all I got was I added 10 green plus 10 purple. That's how many marbles I have in all. 20 goes on your bottom. Your numerator is picking a purple marble. That's my event. That's what I'm talking about. Picking a purple marble, well, there's 10. So that's 10 out of 20, which is, again, 1/2. And finally, last but not least, rolling a number greater than 4 on a standard number cube. That's just a fancy word for dice. So my sample space is again 1, 2, 3, 4, 5, 6. Where are my numbers greater than 4? Doesn't say 4 or greater, it says greater than 4, so that's just 5 and 6. So the answer is 2. Simplify by 2, and you have 1/3. The probability of rolling a number greater than 4 on the number cube is 1/3. Last but not least, complements. Complement. Alright, again, this is another one you're going to want to look at. The sum of the probabilities of an event and its complement equals 1. So an event plus its complement is always equal to 1. So how do we use this formula? Plug in what you know and solve for the missing information, whether it's solving for the event or solving for the complement. So what I mean by that is I will show you. There are 2 red jacks in a standard deck of 52 cards. By the way, if you don't know that there's 52 cards in a deck, you're going to memorize that. What is the probability of not getting a red jack if you select one card at random? So there's 2 jacks, so 2, and I know my sample space is 52 because that's how many cards I have in all. Well, up here, I want to know of not getting a jack. Well, I know that the probability of my event plus the probability of my complement, remember complement was my not word, so I have probability of, I'm just going to put C, is equal to 1. Alright, well, subtract 2 over 52. Remember, because we have to cancel out, so subtract 2 over 52. Alright. Okay, so now I have my probability of my complement, my not one, is going to be 1 minus 2 over 52. So I'm going to rewrite that over here. 1 minus 2 over 52. Well, I don't like that this is a whole number and this is a fraction, so I'm going to change this 1 to a fraction. See, my denominator is 52, so I'm going to make it 52 over 52 minus 2 over 52. Now, do you see what I did? I just took my denominator and I made it a whole. So I had common denominators, because subtracting fractions, you have to have common denominators. 52 minus 2 is 50, and you keep your denominator the same. Simplify, I'm going to simplify by 2, so I get 25 over 26. And there's your answer. The probability of not getting a red jack is 25 out of 26. So 25 out of 26 times you will not get a jack. And last but not least, a jar contains 8 marbles marked with the numbers 1 through 8. You pick a marble at random. So I'm going to list my marbles. 2, 3, 4, 5, 6, 7, 8. What is the probability of not picking the marble marked with the number 5? Not picking the 1. So I have 1, 2, 3, 4, 5, 6, 7. Well, my sample space was 8 because I had 8 marbles. There's 7 numbers that wouldn't be 5. So your answer is 7/8. Now, because Ms. Smith and I and Ms. Head and Ms. Lightoff want you to use this formula, I'm going to show you of the probability of picking a 5. So the probability of picking a 5 would be 1 out of 8 plus the probability of the complement is equal to 1 whole. I just used my formula from up here. How do you get rid of a positive 1/8? You have to subtract 1/8. So I have to subtract 1/8 from over here. The probability of my complement, remember I don't like the way this looks, so I'm actually just going to cross it out. I'm going to change it to 8/8 because 8/8 makes 1 whole and my denominators are the same. Keep your denominator. 8 minus 1 is 7. It's the same exact thing. Alrighty? Probably the complement is probably the hardest thing, so if you have questions, star it and make sure before you begin your classwork tomorrow that you have your teacher go over it with you. Alright, y'all have a good night. Bye.